Okay, so now we're going to dive into day two. But before we do that, there are some helper functions here that I think we're going to need across most of the challenges, in particular these two that print out an array and split on new lines. So what I'm going to do is create a new file called helpers.lua. And what I want to try and figure out is how we can actually create these as helper functions that get exposed. And I've kind of done some Googling here, and I think Lua has the concept of modules. So we create a module, let's call it helpers. And then what you do is you return that. And rather than defining these functions as local, you can say helpers.print table array equals this function. I think that's right. And here we'll do the same thing. Helpers.splitString on new lines is a function. And I think in here I can now say local helpers is require helpers. And I want to see if that works. So what we can do here is in day two, let's just say helpers.print table array hello. So now if I run Lua day2.lua, we get the word hello. Excellent. So that's quite a nice way to ensure that we can simply reuse some of the helpers that we create. So taking a look at day two, the guide to day two talks about rock, paper, scissors. We get a strategy guide here, which will be helping us win. The first column is for what your opponent plays, A for rock, B for paper, and C for scissors. The second column must be what you play in response, X for rock, Y for paper, and Z for scissors. The winner of the tournament is a player with the highest score. Your score is the sum of your scores for each round. Score for a single round is a score for the shape you selected plus the score from the outcome. So suppose you were given the following strategy guide, and this is our input. First round, your opponent chooses rock, and you should use paper. This ends in a win for you. Okay, so first thing to do is take this input and change it into what our opponent plays and what we should play. So let's take this example input. And we'll say, again, local sample input is that, not int, sorry, input. Okay, and let's define a local function part one. And we'll call part one. So we're going to want our lines again. So we say local lines equals helpers.split. What did I call it? Split string on new lines. And we'll give it our sample input. And now what we want to do is we want to go through this each line at a time. If we do helpers.print table array lines, just to check we've got the right thing. Whoops, let me do that again. We've got hello, AY, BX. And I think we need to ensure we've got a blank line there. There we go. Okay, AY, BX, CZ. That is why in our helpers, this input string, it got concatenated with a new line to ensure that if we don't have a new line there, it still detects this last entry. Okay, we will copy that. So that was /n. Yeah. Oh, now we get a blank one back. Oh, we won't do if we store that. There we go. Okay. Yeah, so the reason here, this string.gmatch call added a new line onto the end of it, because otherwise it seems in the event where the last line of the string doesn't have a new line at the end of it, it won't get matched by this expression. So we concatenate a new line on the end to make sure we always pick up the last match. Which is fine with me. So let's go back into day two. Bump that over. So now we want to process each line and start creating almost a list of all the moves that will be played. So we can again say for the integer, the index, which we don't care about, a line in iPairs lines do. And I'm going to create a local list or table called moves. And actually what we'll do is we'll each move itself will be a table with two keys, them and us. So we'll store each move like that. So we know that for a given line, the first character will be their move, and the third character will be our move. So what I'm wondering is, Lua must have a string, Lua string G substring. Str sub S, I, and J. Return another string, which is a substring of S, starting at I and running until J. Okay, this might take a bit of kind of fiddling with. So let's just do table.insert into moves string.sub line, and let's just say 1 and 1. See what that gives us. Oh, and what I need to do now is print the array of moves that we create. A, B, and C. Okay, so that is local their move is going to equal that. So local our move is going to equal string.sub line starting at the third character, taking just 1. Is that going to work? Pair of moves us equals our move, them equals their move. So insert moves, pair of moves. And now printing this is just going to give us tables, of course, because each entry in our list is now a table. So our print function needs to be extended. In the meantime, what I'm just going to do is print our move and then print their move. In fact, I'll do it the other way around. Okay, so our move definitely isn't working. Maybe it's starting at the second character. 1, 2 is 3. Just make sure we have the right line here. Okay, so string.sub clearly isn't doing exactly what I thought. Starting at I and running until, until J. So I'm saying 1. That needs to be until the third index. Yeah, okay, A and Y, B and X, yeah. So I thought the J command, the J argument was how many characters to take. But it's actually at which index to stop taking characters. So to take just the third character, you give the same I and J. Okay. So let's see if we can extend our print table array function here to instead to deal with the fact that we could have this value could be a table. So I'm going to find a function called helpers.print table pairs. I'm sure this is dreadful, Lua, by the way, but this is kind of how I like to learn, is sort of hack my way through it, and then I'll find better solutions later on. Then maybe there's a helper library we could install to make this a bit easier. I don't really know. So for key value in, and this time I think we want pairs input table, because that will work for all types. So I think iPairs is integer based, and pairs is gives everything. And we can print here the key followed by a comma, concatenated with the value. So if I were to now say here helpers dot print table, what was it? Print table key value pairs of pair of moves. Us Y, them B. So them A, us Y, them B, us X, them C, us Z. Nice, that looks like it's working. But we probably want to do that. Yeah, and that's fine. So how can we determine what the type of something is? Type of variable. Oh, type, okay. Do we know what the type of a table is? if I were to just go into day 2 here and say print type of a table. Table, okay. So and therefore what we can do in our helpers is we say if type value equals table, then what we want to do is actually do helpers.print table key value pairs of our value, else we'll just print it. Nice, okay, so that is working. It's a little messy to see. Let's get rid of that there. So we're printing our table array here, and we are seeing, still seeing this output, but we are seeing some stuff in there which looks about right. So print table array. Oh, and I need to do an else here. Okay, us, y, them, a, us, x, b. And let's, after each value, print a comma. Nice, okay. It's hacky, it's not the best debug logging, but we can now check that our table is looking about right. So now we have the moves, we can convert the letter A, Y, B, X, C, and Z into what the actual move is. So we say local function letter to move. So we take a letter in. And we say if letter equals A, or letter equals, I can't remember what it was, something, we will look up in a minute, then we're going to return rock. Let's have a look at the Advent of Code instructions. X for rock. So A for rock. So A and X are rock, B and Y are paper, C and Z are scissors. So it is do we have else if? Else X then paper. Got this wrong. It is, oh no, it's rock, B and Y, and then C or Z, scissors. What have I done wrong here? Missing corresponding end. It was happy when it's like that. Is else if not a thing? Else if is one word. Okay. So now what we want to do is process the moves and calculate our score for each move. So now we can say local scores for moves is going to equal, in fact, we can just say local r score equals 0, and we're going to loop through every move. So we could actually do this as part of this initial loop, but let's do it as 2 loops. So again, we can say for underscore move in I pairs moves do. It's local them equals move them. Can I do that? And local us equals move us. And actually what we want to say is letter to move, like that. Let's just print them, see if this is looking about right. Rock, paper, and scissors, great, okay. So what I want to say is r score plus equals score for move us them. Let's define that function. So the score is the score for the shape you selected plus the score from the outcome of the round. So I'm just going to copy this into here. Okay, so the shape we selected as well. So local score for shape. Let's just set it to 1. We'll say if us equals paper, then score for shape equals 2. Else if us equals to scissors, then score for shape is 3. And it's going to tell me that's unused. Yeah, that's fine. It will be used. Local score for move is, let's set to 0. And if it's a draw, then we set it to 3. So if us is equal to them, score for move equals 3. Else if, okay, so we have to do a lot of else ifs here, because if we need to check if we now want. So if us equals rock and they played, what does rock beat? Scissors. Score for move equals 6. Else if we played scissors and they played paper, then we also get 6. Else if we played paper and they played rock, we get 6. So we could definitely tidy that up, but we'll leave that be for now. And finally, we're going to return the score for the shape, or score for move, plus the score for the shape. So we're going to go through here. We can't do plus equal. R score equals R score plus. And then at the end, we're going to print out our final score. We get 15. So what we can see now is if that matches with this example input, you get a total score of 15. What would be your total score if everything goes exactly to your strategy guide? Okay, so let's grab our puzzle input. And let's paste this in over here. Okay, that's called actual input. So let's go down here. Change that to actual input. 12,535. That's the right answer. Okay. Okay, so now the challenge has changed slightly. The total score is still calculated the same way. But okay, X means you need to lose, Y means you need to draw, and Z means you need to win. Okay, so now what we need is down here when we calculate our move, we say X equals, does X mean we have to lose? X means we lose. Y equals we draw. Z equals we win. So what we need to do now is figure out our play based on that guidance. So I'm going to just change how we structure this a bit. What we're doing is we're calculating moves here and storing them as A, B, C, X, Y, Z. We're going to change that to say that their move is going to be letter to move. String G sub. Then we can, this can become move them. There's a way to surround this with quotes, but I can't remember what it is. Let's do that manually. So our move char is going to be that. Okay, so what we say is if our move char is equal to Y, and then we'll say local R move. Let's just default it to, let's actually just default it to nothing, nil. So if we get a Y, that means we need to draw. So we can say that our move is going to equal whatever their move is. That ensures that we'll draw at this point. Else if our move char is equal to X, we need to lose. Else we need to win. So if we need to lose, then we're just going to have to iterate through this. If their move is equal to rock, then our move is equal will equal, so we need to lose to rock, so we need to play scissors. Else if their move is equal to paper, then we need to lose and play rock. Else finally, whoops, where was I? Down here. Else finally, if they've played scissors, our move must be paper. Sorry, yeah, paper. Okay, so that's the we need to lose case. Else we're going to take the win case. So if their move is rock, we need to beat rock when playing paper. Their move is paper, we need to beat paper by playing rock. If their move is scissors, we need to beat them by playing... sorry, scissors beats paper, and then rock beats scissors. Okay. So I'm just going to change this back to the sample input. We get 3. I do not think that's correct. Now, correctly decrypting the strategy guide, you would get a total score of 12. Okay. So what have we done wrong here? And this letter to move us is wrong now because we are storing the full thing, so let's remove us. 12. Excellent. Okay. So if we change that to actual input, we get 15,457. 15,457. Right. Awesome. So I'm going to finish there. I hope you found that a useful little adventure in Lua. If you have used Lua more than me, which won't be hard, and there are things you think I could have done differently, please feel free to let me know. As I said, this is not me recording a video as a Lua expert. This is me recording a video as a complete beginner, just trying to show you a bit of the language as I were to figure it out and recording as I went. Any questions, please feel free to leave a comment. I hope to catch you live streaming on Twitch sometime. You'll see all my social information on screen as well if you want to get in touch. Thanks for watching.